It's your boy AC. What's up, my friends? Let us begin. Alright, so here's our square root parent function, and we kind of dissect this in the last video. Okay, this is the square root function. How do I know? Well, I can always match, right? What's the square root of 0? It's 0, which is right there. What's the square root of 1, right? Well, it's 1. Square root of 4 is 2. Square root of 9 is 3. So you can see I can easily mark my points. Okay, there we go. Looks good. So now we begin to ask ourselves, well, and let's maybe do this in a different manner. Okay, what if I want to subtract the y values by 3? Well, what's 0 minus 3? Well, I want to basically go down 3 units. Well, I'll take this point, let's move it down 3 units. There it is. Let me change the color a bit. How about we use ourselves a nice beautiful orange? So basically, what if I told you subtract the y values by 3 but don't change the x values? So I'm gonna basically subtract by 3. I'm basically taking these points and moving them down 3 on the y value. 1, 2, 3. Okay, 1, 2, 3. 1, 2, 3. Okay, so here it is. I'm going to basically, the goal, and it's not a perfect graph, but the goal here is I want to take my parent function and I want to shift it down 3. Everything down 3. Move everything down by 3 units. So the question is, am I changing anything to the x values? Well, no. All I'm doing is taking the points and moving them down 3. And what am I doing to these y values if I'm moving down? I'm subtracting by 3. So the equation for this line here, okay, should naturally be, well, y equals the square root of x. I'm not doing anything to the x values. All I'm doing is just subtracting the y values by 3. So this would be the new equation, which is here. Okay, and I can verify it now, right? If I plug in the square root of 0, let me change it to black so you can just see it a little better, my friends. If I plug in the square root, if I plug in 0 into here, we get this. Well, what's the square root of 0? We get 0 minus 3, which is negative 3. Plug in 1. 1 minus 3. Well, what's the square root of 1? It's 1 minus 3. And if we do that, we get negative 2. Okay, plug in the 4 into the x value. Square root of 4 minus 3. Square root of 4 is 2 minus 3, which is negative 1. And that matches our graph. When x is 0, my y value is negative 3. When x is 1, my y value is negative 2. And when x is 4, my y value is negative 1. And I can do that whole thing there. So you see, the square root of x minus 3, well, all we're doing is shifting the parent function down, I spelled that really bad, down 3 units to the y-axis. Okay, so we're shifting the parent function down 3 units. So let's take a look up here. If you were given the square root of x plus 2, well, what are you doing to the y values, right? So try to see if you can make sense of this. What are we doing to our y values from our parent function? Well, we're adding by 2. So take these points here that we see, right? Square root of 1 is 1, 4, 9, and shift them up 2. So now our function is going to look something like this, and I'll change the color. Shift the y, we're adding 2. So just move 1, 2, boom, 1, 2. 1, 2. We're shifting our y values up by 2. Okay. Again, we're not doing anything to the x-axis, which is right here, the x. We're just saying plus 2 to the y values. And you see the x values stay the same. It's just the y values that got shifted up 2, right? That's why this equation here is going to match the blue line. And we can verify it. Plug in 0 in for the x. And we get the square root of 0 plus 2. The square root of 0 is 0 plus 2, which is 2, right? 0 comma 2, which is right there. Plug in 1. What's the square root of 1? Plus 2. Square root of 1 is 1 plus 2, which is 3. And we're going up 3. 1 comma 3. See, you're just adding the x values by 2. You're not affecting anything on the x-axis, just shifting them up or down. So how does this compare? Well, we're just shifting the y values. This right here, we're just shifting the y values up 2 units on the y-axis. 2 units on the y-axis, okay? And that's all we're doing. These are vertical translations, and that's how we do it on the graph and how it shows up on the equation. And so if you look at a couple examples here, let's go ahead and do a few of these here. So the parent function, the square root of x, is shown with points a and b plotted on the graph. Here it is, right? Well, this is just, what's the square root of 4? 2. They're just these 2 points. That's the parent function. The graph of g of x is the square root of x plus 4 is a translation to the graph of f of x. Plot the translations of points a and b from f to g. Basically, I want to graph this. Well, what does the plus 4 means? Well, that just means we're shifting the y values up 4 units, right? Because it's plus on the y-axis. So just take this point and move it up 4 units. Well, be careful because this isn't 1, it's going by 2s. So we're going to move it up 4 units. So that's, okay, 2, 4, so up 4 units. 2, 4, up 4 units. And if you want to, you can even take this point, move it up 4 units. Up 2, 2, 4, up 4 units. Boom. And there it is. We just sketched our vertical translation of this function. We took our parent function and just shifted it up plus 4. Let's take a look at this one here. Well, what am I doing to this graph? Well, now I'm subtracting 6. I'm moving down 6 units on the y-axis. So let's go to our parent function. It's the same problem as 4. Go down 6. 2, 4, 6. Boom. 2, 4, 6. Kapuya. Take this point. 2, 4, 6. And there it is. We just shifted it down 6 units. That's all we're doing. It's just doing vertical translations. And here's a bit of a challenge. We're going to shift it up, what? 3 units. Well, be careful because it's going by 2. So 2 and 3 would be somewhere in here, right? This would be 3. Move it up 3. So this is 2 and then 3. Okay, so we're shifting it up 3 and it's going to look something like that, my friends. And this is vertical translations. Hopefully this makes sense. You have yourself a wonderful day.